Hello everyone. So in this tutorial, we're gonna see how to improvise the Simulink model, like make the graphs look more and more better, and how to change the model so that it looks appealing. So first we're gonna start with this model of tooling robot. So as of now, I just know that this is my plant, this is my control, and this is my disturbance, and I haven't done anything yet. So let's start with writing down a title for this project. So so usually double click here somewhere on the screen, like on the top, and then click on the create annotation. Then that would create. I usually type the headings as an equation. So, so the equation, let's say, so I think this looks good. So now, okay, so we can change the color by simply like clicking on it and say red. Red looks good. So now it's red, but let us make it bold. All right. So this looks perfect. Now let's gonna do how to insert the system equations. So we know that this system has some external disturbances. So now we're gonna do something similar and go to the equations and type about system dynamics. So it's Q dot, Q dot, G of Q equals tau. Yes, so we have some extra term in terms of disturbance, which I'm going to call it as tau d. And yeah, that's my system dynamics. And I want to increase the font size, so let's make it 14. So yeah, it looks better now. So we have named our project, and we have also mentioned the system dynamics so that it would be easy for someone who is looking at this to follow. So now, if I run it as of now, I'm gonna get some tracking. Yeah, I want to track 80 degrees and 60 degrees. So I'm gonna get theta 1, theta 2, and the velocity theta 1 dots and theta 2 dots. So I don't like the background actually or the color. So to change it, right click on it and go to style. So I usually like white background and black graph on it. So I just change it to white, white, black. And I usually use two and white. So what? Let's see what's going to happen with this app changes. Okay, it should be black. Yeah, yeah. So this looks perfect. Now let's do the same for rest 3. So sometimes I want to differentiate like my first state and second state through some colors. So at such times we can just use like right click and different colors which you want, like red or something, and it will show up. So I usually prefer black and red combination. That's it. That's good. That's appealing. So these are the outer lines of the model, like naming the model, writing the system dynamics. So now we have our system running, but I also want to plot some internal dynamics such as my sliding surface. I want to plot my sliding surface. I want to plot my desired dynamics and also match it along with my current desired states, and also match it with my current states and see how my current states track the desired states from initial condition. So for those, let's move this a little up. So I need those things as my outputs. So for that, I'm gonna change the function so that I get those as my outputs. I need my sliding surface as the output. I need my desired states as my output. So now to plot them, I can just put a scope here directly, but that I usually like to put all the plots at one place so that it's easy for the person who is reviewing the file to follow through. So for that, I'm going to use from and go to blocks browser. And I also need a scope. So now let's do it for the sliding surface. You can reduce the size so that it fits in like the same width. So this is the sliding surface, and this scope sliding surface. So and again, I'm gonna do something similar. I'm gonna copy this and put it here. Let me just change the name. We're gonna have something here. I'm gonna say QD. And I need another scope to visualize my desired states. But actually, that's not enough. Just by visualizing desired states, I also need my current states queue. So I need to make another change here. That is, I also need my queues. How they change. So now let's copy this. So let's name it queue. So we have queue, QD, we have QD, I need queue. Here I want to see the error of Q and QD. So I'm gonna do a add block, something like Q minus QD. So I wanted Q minus QD, so let me change it so that then I'm gonna add it here. So I'm just building up my plots one by one. So this is going to be my surface. That's going to be the input from the sliding surface. So let's increase the font size. So I usually right click on them and go to format, font style selection. I usually prefer 16. I think that should be. So similarly, let's rename, plan. Okay, yeah, I'm going to do the same thing and make it 16. Similarly, this is my sliding mode controller. I'm going to do the same thing and make it font 16. I'm going to make this line thicker because this is the most important thing. This is tau. This is what we want to. This is the most important thing, and I'm going to make it 16. So this is thicker. Oh, okay. This okay. Yeah. Sorry about that. This is just a line. So I also want to visualize tau. So let me copy another of these notes and go to tau. So let me name these. So this is my control. These are my errors. I have my sliding surface. I have my errors, and let me increase the font size first. Okay, so usually if you like drag and select all of these, you get this option called create area. So I'm going to create an area for these and just move it a bit down, and I'm going to name these. So it's the same thing. I'm going to create an annotation here and just for plots. So let's name them plots. Okay. These are my plots. I have a controller, I have a sliding surface, I have my errors, and these are my states. These are my states. This is my tooling robot dynamics. This is the whole thing now. Yeah, I have my system dynamics. And let me change it to dark red. Red. So yes, so all the important things, my dynamics, my controller, and this is an external disturbance. So we're just gonna name it as an external disturbance. I'm just gonna make it as the same size, 16 as others. So yeah, I think we have everything required now. The sliding mode controller, external disturbances, tooling robot dynamics, states. Now I'm gonna run it. So let's see. Yep, I have my states. I'm gonna make this one red too, just make it look better. Yeah, so I have my theta 1 and theta 1 dot in black and theta 2 and theta 2 dot in red. So let's do the same thing for my errors. So actually we have both the errors in the same graph, which we can do one thing. We can use a demux and separate the errors. So I'm going to do that. layout. I need two inputs and I want them to appear. You can either choose if you want top or bottom or side by side, but I prefer top and bottom. Apply. Okay. Similarly, I want to visualize both the sliding surfaces differently. So let me do the same thing here too. Let me differentiate the sliding, split the sliding surfaces into two. I want to do the same thing with the controller. I want to differentiate the controller. I have two controls, tau 1 and tau 2. I'm going to change the layout and select number of inputs as 2. So again, I want to change the background of these. So I'm going to do the same thing like right click on the figure style. I'm going to change it to white, black, and I'm going to change the color to black. And I usually like the thickness as keep the thickness as 2. That makes that makes a diagram more clear. Apply. So yeah. So the second one is blue. I want the second one to be red. So again, I'm going to right click style channel 2 red. I want it to be 2. Apply. Okay. So now what we're going to do is run this one again so that we can visualize both bottom and top parts separately. So now this is my controller. Okay, the problem is we changed the channel for the top one, but we haven't changed it for the bottom one. So let me change it here again. Right, and to apply. So I also want to see the legends because this right now this is I just see some switching thing, but I don't know what is what. So I'm gonna go and put legend. Now I have a legend and I'm gonna rename it as just the tau one. Now we're gonna do the same thing with the sliding surfaces as well. I usually prefer red and black combination. And this one is perfect. And again, I want legend here, so I'm gonna put some legend. Sliding surface one. This is sliding surface two. Alright, so we have differentiated the sliding surfaces with different colors, and now all we have to do is the errors. Error goes to 0 eventually. Yeah, that's exactly what we I'm going to change it to the same thing. White, black, black, white, two, black, style, white, black, red, two, apply. Okay, yes, and I'm gonna have to do the legend. Error one. So we have differentiated the whole thing. with the title, system dynamics. And if you want, you can add the control law here with some annotation here again as a control law. But I don't know. It's, yeah, it's up to the user choice if he wants to add the control law. But so you can follow the same procedure as system dynamics, how we added them here. So this is a visualization. I have my states as I wanted. I have my errors, I have my sliding surface, and I have my control law. I have everything. So now I want to copy this diagram for my research purpose onto, say, a Word document or somewhere. So I want to save this basically as a PNG. So what I usually do is I click on File, Print to Figure, the whole thing. If you want all four things in one PNG, you can select this as a whole. So this is my figure now. So since I have this now, I'm gonna select each and every one separately. I just click here on the top, and that's gonna open a property inspector. Okay, so let's go to labels. I've already labeled my theta 1, theta 2, theta 1 dot, and theta 2 dot. All I just have to label right now here is what is my x-axis. So I'm gonna go and hit that x label, the text. So if you want, you can do the labeling individually for all the four graphs. Or if you click on graph one, it's gonna highlight the label for graph one. But right now I'm just gonna show overall label. How so I'm gonna do it for the fourth one. So I'm gonna cancel this. This is the diagram I want to select for the fourth one, and let's do the axis for fourth one. Yeah. So it's gonna be in string time in seconds, and I want the size to be, I usually put it at 20. I think that should be good. Yeah. So I have my time here, and I want to increase the font size of my axis Y. So for that, we can go to the panel. Comes in, yeah, font name and font size. So I want my font size to be 18. I usually keep it too lower than this. So I have this font size now for graph one. So we can do the same thing for graph two. On graph two and go to property inspector, 18. Now click on graph three, go to property inspector, 18. Click on graph three, sorry, graph four, make it. After I finish this, I'm gonna close it. So I've actually increased the font sizes. and I've also labeled them. So let's increase the label font 2. Let's make it 14. Right click on the label, select and right click on the label for the selection. Yeah, the font is font is 14. If the right click doesn't work, sometimes you can just double click on it and it will open up the inspector, property inspector. And let's make it 14. Okay, perfect. Yeah, so I have my theta 2 dot, theta 1 dot, theta 2, and theta 1. So I have this whole figure. Now I want to save this as a PNG, so I'm going to just go to File, Save As. I'm going to choose my folder, and I'm going to name it as States and save it as PNG. So let me go check it, how it turns out. Like in the PNG, and we're also gonna see if I paste it in Word how it's going to look. Yep. I think this if you are making a PDF out of this, I think it still is very clear, and if it is not actually that clear, we can go and change the line sizes of the graph, and maybe we can even change the font sizes accordingly, and I think this should be okay. Yeah, this should be good, right? That we have created a graph for a like a PNG for states, we can do the same thing with our control law. So now here for control law, I don't want both of them to be on the same figure. I want each of them to be individually created as a PNG. So for that, right click on the graph which you want to create as a PNG and print display to figure, and you get this figure here. So then I'm going to open property inspector, and yeah, it's updating. So I want my X label to be time. So string. I also want title for it. So I'm gonna do is pick a title. So title is going to be control log 1. Again, I'm gonna make it 20 so that it's here. And I also want to change the font sizes. So the font sizes, oh wait, let's label the Y label too. So for the Y label, click on the Y label and go to string. And this is tau 1, and I'm going to make that 22, 20. So that's done. So all we are left with is the font sizes, which are very small and which are not clearly visible as the labels. So I'm going to go to property. Look for access. So once I'm here at the axis, I'm going to look for the font size. So the font size, let's keep it at 18, and this is what we got. Okay, let's make it 20, the same size as the thing. So this is what we got for that font size. So now it looks perfect. So now I'm going to close it, and I'm going to save this figure file as save as. Yes, so I'm going to save as control 1. Now let's go and check how it looks like. So this is my control 1 in the PNG, and it looks perfect. Oh yeah, there was a small overlapping which I didn't notice here with the tau 1 coming on the graph. We can just pull it up in the MATLAB. Let's do that. We can just put it up. I forgot to change the font of this one, so double click on it and make it. Now let's save this one. Replace this. Yeah, so let's see how this looks. Yeah, this looks clear. Like we have completely labeled diagram here. Let's see how this one looks in the Word. Yep, this is perfect. Now let's see by converting them into PDF, because that's how we usually upload most of our assignments or documents in. So let's check how it looks in the PDF. It's opening now. So yeah, read mode. So this is how it looks in the PDF, and I think it's pretty clear. Yeah, you can actually avoid these sites by carefully selecting, like, sometimes if you, I'll show it. So here the problem was that I was clicking on the diagram. You can actually avoid them by moving it slightly, and I think now, okay, if you click outside of the diagram, it's gonna open this borderline if you see this one. So I'm gonna arrange it in such a way that that's not visible anymore. So I think it's not visible anymore. Now you can go and save your diagram again, and you won't be finding this, you won't be finding the borderline here on the right edge. So this is how I usually name the diagram, and like create like a documentation for something, so that if I like come back and look at it after maybe 1 year, I still know what's happening. Usually I tend to forget things after some time, so this helps me, and I just know where to look for my plots, and I know what's this block, what's this block, and what are these and stuff. And yeah, i think I think that's it. uh, Thank you so much. Bye.